In this video, we'll generate a standard Yocto development image for the PolarFire SoC Icicle kit, program it to the board, and test it. To do this, we're going to follow the steps in the README of the Yocto BSP repository. In the build instructions section of the README, there's a link to the host PC setup for Yocto, and here we can find the required packages. So first, we need to install the repo command by Google. We can copy and paste the commands from the installing repo instructions into a terminal to execute them. Now that repo's been installed, we can return to the README for the Yocto repository. And now we can install the required packages for the build host from the Yocto project reference manual. In the Essentials section here, we can copy and paste the install command from this documentation and paste it into a terminal to install the required packages. Now that that installation is complete, we can return to the README once again, and we just have the other dependencies listed off here to install. And again, we can just copy and paste these commands into our terminal to install the required packages. Now that we've installed all of the required packages, we can return to the build instructions section of the README. And now we can start by creating our workspace. For this example, we're going to create a workspace in Home, Work and Yocto. So let's make sure that we've a terminal open in this directory now. The first thing we need to do is make a Yocto dev directory and change into it, and then initialize our repository from that directory. Now that we've created the workspace, we want to make sure that it's up to date, and we can do that by copying and pasting the repo sync and repo rebase commands from the README into our terminal. Now that the sync and rebase commands have completed successfully, we can set up the bitbake environment by copying the command shown here from the README into our terminal and running it. Now that the bitbake server has started up, we can get started running a build. We have several different machine targets we can choose from, and different images we can build for shown here. In this example, let's use the default machine of an Icicle kit, and we're going to build the MPFS dev CLI image. So let's copy and paste the bitbake command into our terminal now. Now that the image has been built, we need to program it to our Icicle kit. To do this, we need a terminal connected to MMUART0 to communicate with the HSS. To do this, we'll use PuTTY, but you can use any terminal emulator you would like. Now that we have the terminal open, if we restart our Icicle kit, or power it on now, the HSS will start up. And if we interrupt the HSS boot by pressing any key, we get the command line shown here. Yeah, the Yocto README has instructions on how to copy an image to the Icicle kit. The first thing we need to do is make sure we're in the build directory, which we are, and we can see here in the terminal. And then we can use the zcat command to unpack our image and dd to copy it over to our board, which will be mounted as a flash device. So we need to find the drive identifier for our board. To find the drive identifier for the Icicle kit, let's get a list of the current drives connected to my PC by doing an ls of /dev/sd and I have dev SDC connected currently. If I return to the HSS and enter USB-D MSC and hit enter, we'll put the Icicle kit into USB flash drive mode. And we can see that I have a drive pop up and get mounted. So if I do an ls of dev SD once again, we now see dev SDA and several other drives have also been connected. Now that we know our drive identifier, if we return to the README, we now know the value to replace the X with in this part of the command. So if we copy and paste the command shown here from the README into our terminal in the Yocto build directory, and go back and update /dev/sdx to be /dev/sda. And now, if we hit enter to start the copy operation, our Linux image will be copied over to the Icicle kit. You can see the progress printed out in both the terminal for copying the image and in the HSS console. Now that the image has been copied to the board, let's open up a second terminal and connect it up to MSS UART1 to view our Linux messages. Now, if we return to the terminal for the HSS and enter Ctrl-C, we can unmount our drive, and then if we enter boot, we're going to start up the Linux image. If you get some MUSB errors, like the ones shown here, you can disconnect the micro USB cable connected to J16 to get the errors to stop. Now that the image is booted, we can log in with root and then let's change into the home directory using cd/home. And if we do an ls of this directory, we can see we have the root folder, and that's about it. Now let's test out one of the included text editors. We can create a text file using the Vi text editor by entering vi followed by test.txt, and this will open up a text file for us, and it's empty for us to enter in some information. We can exit Vi by entering :w to write our file, and then :q to quit. Once we're back at the command line, if we do an ls, we can see our test.txt file, and we can open it with the nano text editor by entering nano followed by test.txt. And when this text editor opens up, we can enter in some text, such as hello for example. Then we can save the file by entering Ctrl-X and then hitting enter to write the contents to memory. We can also, for example, open this file using the Vim Text Editor, and we can see that here. And if we enter :q, we can quit. There are several other text editors available, and in our next video, we're going to show you how to add a text editor that's not included in the standard build to a build, so you can use it for your development.